Hi everyone, I'm Sharon and welcome back to another episode of Mania, Science with Sharon. Today we are going to be exploring the science behind Cartesian divers, and we'll be talking about principles of air, three main principles of air. We're going to talk about buoyancy, and we're also going to talk about density and what pressure does to change density with air. I've pre-made our experiment today, but I can walk you through the steps that you need to recreate this at home. First, we're going to need just your own basic straw. I got this one from McDonald's. And cut it into like 1.5 inch long-ish straw. And then you'll need some paper clips. And I actually needed 3 to get my diver heavy enough to work for the experiment. So before you fold your straw up, what you're going to want to do is string your paper clips together. And so that one end you can clip onto your straw, and then the other ends are just going to dangle freely. So you're going to want to string your paper clip together like that. Then you're going to take your piece of straw, fold it in half so it looks like that, and then you're going to use your paper clip to clip the straw pieces together. So it's going to go, and I'm doing this backwards, which is silly, in between, so it'll look like that. And it'll look like a little umbrella with a bunch of paper clips dangling off of it. To make sure it floats properly, you can get a non-sealed jar of water and stick it in there. It should kind of sink to the bottom but stand straight up. See that fella right there? So that has just about the right amount of buoyancy for this to work. So I have one pre-made and I've put it into a sealed environment. And what I mean by that is it's living pretty happily. Come on, silly thing, so people can see you. Right in there. The very tippity top of it is poking out. And if you notice here, it is sealed. There's a little bit of air here at the top, and the top is sealed so that no air can get in. So you want to make sure that that is on there good and tight. So now we're going to talk about the principles about why this works, and then we're going to see it in action. So we are talking about 3 different principles of air here. The number one thing to remember is that air has weight. Air is not nothing. Sometimes we think air is nothing because we can't feel it, we can't taste it, we can't touch it. But air is something. We don't live in a vacuum, and there's lots and lots and lots and lots of different types of things that are floating around us all the time, mostly gases. So we have oxygen and hydrogen and nitrogen and carbon dioxide and all kinds of different gases that live happily in our atmosphere. And all of those gases have weight, and they are pressing down on us. The gravity of the Earth holds all those gases tightly around it, and that's our atmosphere. So if we're talking about diving terms, we're under 1 atmosphere of pressure as we're sitting right here on the surface of Pueblo, Colorado. Another thing that you need to remember is that air does occupy space. It seems like we have nothing around us, right? But it's all air. We aren't in a vacuum. And air has mass and air has density, and so it does take up physical space. We can compress air, we can expand air, but it does take up space. And sometimes it's hard to see that without a sealed experiment like this. And number 3, like I was talking about with our 1 atmosphere of pressure, air does exert pressure. So we are being pushed down on by an entire atmosphere of pressure walking around on the surface of the Earth. Other places that don't have atmospheres don't have that pressure, and that pressure seals heat in. It allows us to have weather systems. Pressure is great. And another thing that we're going to talk about here is the concept of buoyancy, talking about air pressure. So our little Cartesian diver, can you see him? Let's see if I can turn him so you can see him. He's really desperately trying to not be seen. Our little Cartesian diver is buoyant because there is a little bit of air here, and that air is less dense than the water around it. But the air in the bottle right now, under zero pressure, has the same density as the air right there in the top of our Cartesian diver. But if we change the pressure of the air, in other words, we're going to exert pressure upon it so the air is more pressurized, sort of like what happens in weather. Sometimes we have low pressure and it pushes clouds down closer to us for rain, or high pressure and the clouds stay way up at the top of the atmosphere. If we change the pressure in the bottle by squeezing it, the density, the buoyancy of this little fellow is going to change. And we'll see what happens with its buoyancy as we squeeze the bottle. So are we ready? 1, 2, 3. See? It's not buoyant anymore. The pressure that we've exerted on the bottle, which has changed the pressure of the air, has made it so that the air pressure up here is heavier than the air pressure down here. Or, I'm sorry, the other way around. The air pressure in here is heavier than the air pressure up here, and it sank. So if I stop squeezing the bottle, it goes back to normal. Squeeze the bottle, down it goes. Let it go, back to normal. Squeeze the bottle one more time, down it goes. So can you think of any other types of things that have that exact same buoyancy? Things like submarines. Submarines operate under the same pressure, same principle, but the pressure is different. So obviously we're not changing the air pressure on the surface of the water, but the way that submarines change their buoyancy is by changing the air pressure inside the submarine. So they have ballast. Old submarines actually had really actual ballast, like sandbags, but newer submarines vent air or increase the pressure of the air inside the cabin to allow the submarine to rise and to fall. Because it's a sealed system, much like this one, it works with the principle of buoyancy because, again, air has space and air has weight. So if we're changing the pressure inside the submarine by pushing in more air or pushing out more air in creates more pressure, more weight, the submarine goes down. Air out, it releases the pressure, releases some weight, the submarine goes back up again. So this is a really cool way to see these really big atmospheric forces, like the pressure of air and the weight of air, in a really tiny little system that you can build at home. So let's just look at it one more time because I think it's really cool. Ready? Pressurized system, down. Regular system, up. Pressure, down. Regular system, up. That's our science experiment for the day. Like always, please go ahead and drop me a comment if you have any questions, if you need more clarification on how to build this at home, or if you just want to say hi. I'm always happy to answer them. And until I get to see you guys again in person, stay safe and stay healthy and happy making.